Okay, so we are live on YouTube now. No jokes now anymore. Okay, so welcome everyone to the second conference day of the Exchange Reality event. I'm happy that so many of you are here also to listen to the talks of this second thematic session of today. So the topic of this session will be XR for industry and healthcare. And as yesterday, we will have today also 3 paper presentations. So let's just get started. The modalities are as usually known. So if you have any question in the audience, just please put it either in the chat or in the question and answer tool. And Franziska Bruckner, who will be my co-host today, and we will be very happy to get your questions and post them directly to the speakers. Let's start directly with the first speaker. Let me briefly introduce to you Irene Reisner-Kollmann from the University of Applied Sciences, Upper Austria. She's already here on the panel, and she will present today a paper written together with a colleague of her, Andrea Aschauer, also from the University of Applied Sciences, Upper Austria, and the title is Design and Implementation of Asynchronous Remote Support. So please, Irene, the screen is yours. You can start your presentation.
Okay, I share my screen. Can you see it?
Yeah.
Perfect. Yeah. Okay. So thank you for the introduction. I will present today our asynchronous remote support system, which I developed together with my colleague Andrea Aschauer. So let me start with a typical situation, which was the inspiration for this system. So imagine that you have a machine at a customer site, and this machine needs some repair or maintenance. So the first step is often that someone from customer service goes to the site and takes a first look, captures a lot of data which is necessary. And then afterwards, someone in the back office takes a look at this data and based on that, creates an offer for the customer and gathers all information and additional data which is necessary. And finally, a technician accesses the site and gathers all this information, and based on that, does the actual repair. So everything's fine again, but sometimes, maybe at a later time, something has to be repaired again at exactly the same machine. And in this case, it's very beneficial if you can access all this data again. So also either if you're on site for a mobile user or also for a user at a remote location. So based on that, we defined the following goals for our system. We want the system to exchange spatial information between local and remote locations. We want to generate a documentation for each of these maintenance or repair cases. It should be possible to exchange information over time so that every user also can access the data whenever the user has time for it. So it's not necessary that all users have to be online at the same time. We want to include existing data from other sources. This could be, for example, user manuals or instructional videos, because often there's already a lot of data available. And finally, it's important to keep the mobile app as simple as possible, because then it can also be used, for example, by customers themselves that are not that familiar with it. And also the goal is to capture a lot of data for the people that are on site, because it's often not that easy to go back again. As I already showed you, there are two different roles. There are mobile users and there are desktop users. So the mobile user has usually a tablet or a phone and is really located on site. The desktop user, on the other hand, is usually located somewhere remotely and doesn't have access to the actual three-dimensional scene. So the mobile user has an augmented reality view where the spatial information is visualized in 3D, and the desktop user only has two-dimensional views available. As I said before, the main task for a mobile user is to capture and view data, and more time-consuming tasks are useful only for a desktop user. The mobile user is, in our case, mandatory because we do need access to the spatial information. We do need access to the 3D scene, and we need screenshots and all that stuff. The desktop user is very important for the use cases we had in mind, but it's still optional, and there might also be use cases where only mobile users access the data. Okay, here is the architecture of our system. So all our data is stored in anchors, and each of these anchors has a three-dimensional pose, two-dimensional screenshot of the camera view, and the actual content itself. All the data is stored on a central storage unit and can be revisited from any user at any time again. Only the mobile app is able to create new data, as I said before, because we do need the actual scene for creating data. Both applications can view and edit content, and in our implementation, we decided that only in the desktop application, data can be deleted again. The reason is, again, mobile users should focus on capturing enough data and on viewing the data, and the users of the desktop app, they have enough time to organize the data and then delete something that's really not necessary. So here you can see a screenshot of the mobile app. On the right top corner, there are some visualization options, for example, to include augmented reality info and switch between some modes. Then the icons in the center of the image indicate that here is an anchor, and in this case, there is an image, a video, and a document attached to the anchor. And the green buttons are used for creating new anchors. And there are multiple buttons because we can attach annotations, video, or audio. And here is a screenshot of the desktop app. In contrast to the mobile app, here the background image is really just an image and not a live video view. And you can see it's possible to create annotations on top of the screenshot. And on the left side, it's possible to select anchors and also to filter the anchor list based on some content. And on the right side, it's possible to select and add content for the selected anchor. Okay, now I would like to present the different content types we have included in our system. As you have seen before, there are annotations, which are the main spatial information we have in our system. So there are simple scribbles that can be created with a standard drawing tool on top of the created screenshots. And in the mobile app, we have two different visualizations of these annotations. In the instance view, which you see in the top image, the annotations are directly overlaid to the camera view, so it's also possible to look at them from different viewpoints. And in the icon view, all annotations are just indicated with an icon at the 3D location. And when the user clicks on this icon, then the selected annotations are shown full screen and with the original screenshot. Then we have included some other content types. Video is useful for the mobile user to generate an overview of the whole scene. But it can also be used to include external data such as instructional videos. Audio is very useful for mobile users because it's hard to type text into the smartphone. So it's very easy to quickly capture some additional information. And documents can be any external file for additional information. So in our use cases, we mainly thought about user manuals for this kind of content type. The system is very expandable, so any other content type can be included. We think about including interactive elements in the future. So for example, step-by-step instructions or checklists would be very useful for many use cases. Registration is a very important topic for almost all augmented reality applications. So in our case, it's important that anchors are located at the same pose whenever a user revisits the scene. So we implemented 3 different registration techniques. The first one are cloud anchors, for which we use a Microsoft Azure Spatial Anchors. So this is very convenient for the user because it's fully automatically. The only problem is that it might fail if the scene really changes a lot. Therefore, we also support markers. This means no marker has to be placed at the same location in the scene. And from that, we register all anchors. Usually the marker cannot be positioned permanently at the customer side. So the user can see the correct location from the screenshots from previous sessions and then just reposition it again. And finally, we provide a manual registration where a user aligns a screenshot from a previous session with the current camera view. This is very inaccurate and should only be used as a fallback solution if all other registration techniques are not available. For example, if no marker has been placed and Wi-Fi is not available. So finally, I'd like to share some implementation details. We used Unity 3D because it's easy to share the code between the mobile and the desktop app. We used the AR Foundation, which is the unified API for AR Core and AR Kit provided by Unity. So currently we support Android and iOS for the mobile app, and we have a Windows application for the desktop app. For our partner, it was very important that they might share the data with other software units. And therefore, we decided to use standard file formats for whenever that's possible. So most of the data can be viewed with standard software. And only the spatial information is stored in additional JSON files and can also be shared easily with any other software. Okay, now I would like to show a very short video. I hope you can see it. So this is the mobile app. You saw the augmented reality feature points in the beginning. And now a few screenshots are taken. Would also be possible to create annotations right here, but in this simple use case, I just created pictures. When the project is opened in the desktop app, it's possible to view all the pictures. And then in this case, a very simple annotation is added. Yeah, we decided for very, very simple drawing tool, because for anything more complicated, it's usually better to have some external data. Now the project is open again with the mobile app again, and auto registration was used, and then the icons pop up automatically, and the annotation is shown directly over the camera view. So to summarize, I presented an asynchronous collaboration system where mobile on-site and remote users can share spatial information over time. And for the on-site users, the main benefit is that the augmented reality view allows them to view the data exactly where they need it. So thank you for your attention.
Thank you very much, Irene. Are there any questions, either from the audience or from the other colleagues here on the podium? I saw there was one hand actually raised in the audience room during the talk by Leo. Was it a question, Leo? If yes, can you please just briefly put it into the chat so we can follow up on this? And perhaps let me start in the meantime while the people are writing with a brief question. So you developed the application with the primary device being the mobile for the remote side. Have you also thought about addressing augmented reality glasses such as the HoloLens or other devices?
Yes, definitely. We thought about that, and yeah, it's clearly the next step to extend the system to glasses. It was maybe just the implementation time that we didn't have it so far. So we started with the mobile device, mainly also because it's available and all people have a smartphone, so it's easier to start with such a system. If it's really used more often, and if classes are more widely used, it's definitely a benefit, especially if a hands-free solution is required, because the technician wants to actually do something and at the same time see the annotations.
Okay, thank you very much. In the meantime, some questions popped up here in the chat. Let me start with the first one by Julia König. Can information about repairs on, for example, the same model of the coffee maker be connected between different customer accounts?
Theoretically, yes. If the registration is working. So for Asia, I'm not sure. I mean, the coffee maker might be too small and there's too much environment. But yeah, for a large machine that looks the same at different customer sites, yes, it's definitely possible to use the information for multiple instances of the same item. And also with the marker approach, it's also possible if you have some specific spot where you can put the marker so that it's the same, then yes, that's possible.
Okay, thank you. Another question popping up regarding the network connection. I also wanted to ask this actually. What do you need like a constant network connection, or is it also possible to have some of the data like stored locally and then transmitted once you come back online?
Yes, very good question. Yeah, we worked together with the company and they told us that some factories there is no Wi-Fi available, and it's very important to them that everything works locally. So if you create a new project, it's first stored locally if there's no Wi-Fi, and then if the user reconnects to the system at a later stage and there is a connection, then everything is uploaded to the server. And the other way around, the user has to open the project somewhere where Wi-Fi is available, and then later on it's possible to open the project again. There is the difficulty that everything needs to be synchronized. We haven't included that in the system, so yeah, this needs to be done if it's really rolled out, because of course if everyone has a local version, then it's difficult to see what's the newest version, how can we merge these. We didn't look into this right now, it was not part of this research, but it's an important task when the system is really rolled out in the future.
Okay. Perhaps any comment or question from the podium?
Okay, yeah, from my side, I like that you brought up the coffee machine, because today in the morning at the hackathon session, we asked the participants, what brings you joy? And almost everyone said coffee.
Yeah.
So, yeah.
Very important.
Yeah.
And one of the devices I have at home.
So I see it right. You tried it out on the coffee machine, and then the app, and then you implemented it at the company, or how did it work? Because you showed us you tried the device out at a coffee machine, that was your like prototype, and then you diverted it to the companies, or how did it work?
From our implementation, I tried it out that everything that was close to my work. We haven't rolled it out to the company. We delivered some prototypes. They are currently testing it, but not systematically right now. Just especially difficult at the Corona time. So yeah, I mean, the system is completely independent from what is located in the scene. So it can be any device, any desk or anything else. The only requirement is that it's most of it is not movable.
And maybe some more serious question then about the user interface. I mean, I like it a lot that it's like very, very simple and everyone can use it. But do you think about also like overhaul this, or are you planning to make a more sophisticated design? What's your plans there?
No, actually, that's not our plan. That's more, yeah. If I mean, definitely useful to overhaul this and to do a user study and then maybe come up with a better user interface. But it's not really our expertise, so we ourselves won't work too much on it.
Thank you.
And I guess also that you're also limited on the device side, because you cannot have a very highly sophisticated user interface, but you then have to use the mobile phone to use the user interface. So you cannot have very precise or exact gestures or touch interfaces. So I guess that's also why the simpler the better, in my opinion.
But yeah, course, this was our approach.
Sorry. But of course you could already like implement like circles or stars or like predefined things that you could use. I was rather thinking in this direction. It should not be too complicated, I think, because otherwise it's confusing for people with no experience.
Yeah, we had a much more complicated drawing toolbar in the beginning. And then we decided to remove almost everything except the very simple drawing tool. Yeah, it's usually the annotations are more of an information that look at this, or more a pointing direction. I don't think that people will really make sophisticated drawings.
Okay, then thank you very much once again. We cannot have like a real applause here, but we try to have the best as possible virtual applause for you. And let's continue and move on to the second presentation of today. So you see here together with me on the panel already Renan Guerrese. Actually he could now present live, but we didn't know before that he is still somehow trapped in Sweden. He just told me before that actually he should already be on his way back home to Brazil, but because of the current situation, yeah, he has to stay a bit longer here in Sweden, where he currently is at. So what we did is that we prepared a pre-recorded video of his presentation just in case, and that's also the one that we are going to show you now. So the title of the paper is a proposal for augmented situated visualization towards EMC testing. And this is a paper of, for sure, Renan Guerrese, together with his colleagues Emil Nielsen, Per-Erik Andreassen, and Anderson Maciel. And these are both researchers from the Universidad Federal do Rio Grande do Sul in Brazil and from Halmstad University in Sweden. And please, Alexandra, can you start the video for us?
Hello everyone, my name is Renan Guerrese, and I'm here today to present a work I've done in my period abroad at Halmstad University in Sweden during my master's program at UFRGS in Brazil. This work is called A Proposal for Augmented Situated Visualization Towards EMC Testing. So regarding the focus area of this work, situated visualization is basically a mixture between data visualization and augmented reality, where you get to see and perceive relevant information to the environment you are currently located at, particularly in a way that helps the user to identify the 3D position of each piece of data. Here in this image, for instance, you can see a user interacting with an example of that, inside a classroom showing data relevant to it. This sort of visualization has proven to help users in different tasks involving decision-making, including gains in accuracy, time taken, and cognitive effort in different tests. In electrical engineering, EMI stands for electromagnetic interference, which is a common problem where different electrical or electronic devices interfere with each other, giving their natural electromagnetic radiation. In this traditional example here, we see a person using a simple electric trimmer. Here, both the radiation emitted from its motor and the one from the electric energy wiring here causes a TV broadcast nearby to be disrupted. In order to understand and deal with this phenomenon, a field study was created, named electromagnetic compatibility, or simply EMC. Researchers in this area commonly use different pieces of equipment to read, test, and analyze the radiation propagated from different devices in order to understand how they may affect the environment where they're supposed to work in and other devices there. The two most common ways to do this are using an EMC scanner, like the image on the right, and an anechoic chamber, like the one on the left. The EMC scanner is a device roughly the size of a 3D printer, which is able to measure the EMI in a high range of frequencies. The radiation analysis is done with a near-field probe attached to an XYZ robot, which reads and later on renders a 3D graphic visualization of the electromagnetic field around the tested object. The scanner is usually meant for precise readings in small components like circuit boards. The chamber, on the other hand, is meant for large-scale devices. The readings are done with a fixed antenna. The tested object is commonly placed atop a slowly spinning circular platform, which rotates for the radiation to be collected from all sides. The chamber is built as a Faraday cage padded with absorbing material, as to avoid wave reflections and external influences. So here at Halmstad University, we have ECH, the Halmstad Electronic Center, which is a facility that works with EMC testing, both with EMC scanners and one of these anechoic chambers. Here we have a video presentation of the facilities. Unfortunately, my Swedish is not good enough to explain the subtitles here, but I can assure you it's a very good facility. Here we can see some examples of the data EMC experts currently use to analyze and test devices. They are usually simple 2D graphics indicating the magnitude of the electromagnetic field, and sometimes these are color-coded. On the left, we can see a solid 3D graph, which, besides occluding most of the data by itself, makes it a bit hard to identify where the tested object was. On the right, we can see an attempt to place data overlaying a schematic for the actual circuit board tested. This type of visualization is currently done ad hoc though. What we're proposing to do here is to use situated visualization in favor of EMC testing. This means that we're going to render the EMC data read directly surrounding the actual components and devices being analyzed. In this way, we expect to help EMC analysts to easily identify where and how EMI is happening in their tests. In this first draft, we propose two different approaches. The first, we named Desk Scale EMC VIS. This one uses the data read from EMC scanners and places them over and around small electronic parts and devices. For this, we intend on using computer vision frameworks such as the Vuforia engine to identify the component being analyzed and select its dataset to be rendered in augmented reality. In this next approach, called Room Scale EMC VIS, broader data from different devices can be viewed and compared in the same environment inside the chamber. In this sketch here, the user is visualizing from an allocentric perspective, where a smartphone is used as a visual portal. Much like that, we can use AR head-mounted displays, like the HoloLens, to render the same information in an egocentric perspective, possibly making it easier for the user to understand the location of each piece of data. So in this video here, we'll see a prototype of some of these concepts, including a preliminary interaction method using the user hands and a hand-guided virtual menu. Here the user is wearing a Microsoft HoloLens to see the virtual data, which also scans the real chamber environment into a virtual mesh. The EMC fields here were measured based on the actual antenna that's placed at the top of the table there. So we're currently working on testing the first draft of this prototype with a set of EMC expert users, so we can find and address any problems with the visualization or interaction methods, as well as getting suggested different ways in which this paradigm could be explored. This test will be held inside the anechoic chamber with a set of interference avoidance tasks, where the subjects will analyze 2D EMI data between two different antennas and move them around as to get an optimal placement, minimizing the interference between them. After that, free experimenting time will be provided to the same users with different instances of 3D data, where they can select multiple frequencies of the data read and compare them. These tests will be followed by a gathering of all participants as to initialize a group discussion regarding the approach. So in conclusion, this was a preliminary work to propose whether and how situated visualization can be helpful in EMC tasks. Thank you all for your attention.
Okay, so thank you very much, Renan, for this interesting talk, even if it was pre-recorded. I think still it was more or less looked like live.
Okay.
So thank you for that. Yeah, perhaps please into the audience and to the podium. Think about any questions that came up when looking at the presentation, and write it to me or to us in the chat. And while you do this, let me start with a first question. First of all, thank you for this very interesting work. Actually, it's quite well linked to work that we are also doing here at our university. So definitely, I think we should or could stay in contact, and let's see what comes out of this. I mean, we're not talking about EMC here at our university, but we're also talking about situated visualization of other data, for example, in the agricultural domain, which could be interesting.
Nice.
So in between, the first question already popped up. So what is your experience, or what are the experiences with Vuforia in larger spaces or larger rooms?
Yeah. So first of all, thanks for the time here and your attention. And regarding Vuforia, I did work with it in the past, but only in small scale prototypes, usually with 2D markers. I haven't worked with Vuforia in at least 1 year, so I don't really know how far did they advance in using 3D objects. I mean, like 3D real objects as markers instead of just 2D ones. I can't really say about larger spaces, but since based on what I knew beforehand or worked with Vuforia, I only plan to use it in the desk scale prototype, so the smaller scale. So what I intended on doing was using the images of the tested circuit boards or whatever we would be testing, and use those as either 2D or 3D markers to place the data on top of it. But after my time here, I only this far at least, I only got to work with the larger scale prototype. So I didn't really use Vuforia for that. But yeah, so I wouldn't really be comfortable answering that.
Okay. Okay. Perhaps another quick question that came up to my mind when I'm having a look at the video. How do you get the data actually from the antennas? Is this you gather it live and push this somehow to the HoloLens then, or is this pre-recorded and you just get it once and then just display it, or is this really like a live visualization?
Yeah, so the data, especially in a large scale, like the chamber, it takes about well, at least the 2D data takes about like 10 minutes to read like the whole environment, because it needs to like slowly spin the device it's reading. So yeah, it's not live. What I am doing in the video there, I just got some already pre-recorded data. I'm parsing it in the HoloLens and displaying it, rendering and displaying it. But what I did manage to do like after that was to get the data like as far as soon as it is ready from the computer that deals with the chamber or the readings, transmit it to the HoloLens via local network, and just render it there. So it's not live, but it is live as soon as you read it, because
Okay.
it does take a while to get everything.
Okay, thank you. In between, a question from Victor did come up. Perhaps you can just pose it yourself, Victor, since you're on the podium.
Yeah, I was just wondering about the anchoring, like the positioning, because it looked in the video that was really well positioning as the person was moving around. So how was that? It always fixed on the same position for the demo sake or for the testing, or it could be in any place in the room? How do you deal with?
Yeah, so the HoloLens does have like their own system to deal with spatial mapping. it's what they call. So they like while you're using it, it's constantly scanning the room and creating a 3D mesh of it. So as soon as you get something into your app and you place it there, it's gonna do its best to just keep it exactly where you placed it. So as soon as you get the data and you place it where you want to see it, usually it's gonna stay exactly there. It does have some problems, especially with lighting conditions and the color of what you're looking at. So for instance, if I get the HoloLens and I like face like really close to a wall, like a blank wall, it's not really gonna know how far away I am from anything, since it's only gonna see like blank. So it is gonna like lose completely itself. So you need to like kind of manually put everything back in place. But yeah, as soon as you get it somewhere, when you load up the application again, it's gonna be there, or at least it's gonna do its best to keep it there.
Okay. Any other question from the podium or from the audience to Renan? Yeah, Franziska?
Yeah, I was wondering because in your video you said this is a prototype. You're now going back, hopefully soon. What will follow up?
Yeah. So since I wrote the short paper for this conference and I made the video, I did get a bit ahead in the project. So I did kind of finish what I intended on doing. I am mostly working testing with different interaction methods to both replace, or well, not replace, but reposition the data in the space you're in, without using any sort of controllers, and also to extracting information from the data. So that's gonna be like my whole master's dissertation is gonna be about that.
Mm-hmm.
And hopefully it's gonna come out in a next work that I'll be able to show you.
Okay.
Maybe in the next conference.
Yeah. But will we be able to continue your work in Brazil? Do you have like a similar facility there?
Yeah, so not really. I am still gonna work on the interaction methods, as you don't need to be like precisely inside the chamber to do anything. You just needed to like measure the data or collect it. So yeah, and also in Brazil, I'm not gonna have a lot of contact with experts in the EMC area, because those are actually from here in Sweden.
Mm-hmm.
So as soon as those tests are done, I don't think I'll be able to, myself at least, pursue working with the expert level of the visualization.
Mm-hmm.
Okay, so yeah, once again, a virtual applause for the second presentation.
Thank you.
And now comes something interesting, because we are switching the topic, but we're not switching the speakers, which means that is one of the hypotheses that XR experts are independent of the thematic field XR experts. So actually, we're switching now from the industry part of this session to the healthcare part of this session. And yeah, let me welcome again here on the panel Renan Guerrese and Victor Oliveira. And they are going to present again using a short video, a paper from the healthcare domain called Empathy and the Phantom Limb Sensation, a multisensory experience for embodiment of amputation. And this paper is written again, as I said, by Renan and Victor. And the other authors are Amy Calepso, Rafael Valer, Jonathan Iquipasa, sorry for the bad pronunciation, Luciana Nedel, and Anderson Maciel. And this is a joint work, again, of the Universidade Federal do Rio Grande do Sul in Brazil and St. Pölten University of Applied Sciences here in Austria.
Yeah, maybe that you should mention that Victor is actually a member of.
Yeah, actually, that's an interesting link, which I also discussed briefly before with Renan, because actually Victor is coming from the same university as Renan is working on, but the two, so Victor left to work here in Austria together with us before Renan actually joined the group, so they know each other just from some meetings, but not very detailed in person, which is interesting. But so this is also the connection to this Brazil University here from Austria. That's an interesting fact, which also shows how small the world actually is in this field, and how international actually also the research is, because we're talking about a joint research of researchers from Brazil who are doing an external semester in Sweden, and one of them is now in Austria. So yeah, that's how the world in this field looks like at the moment, which is actually great in my opinion. So please, Alexandra, let's start the video. Thank you.
Hi everyone, my name is Renan Guarese and I'm here today to present a work I've done with some colleagues and professors, both from my home university in Brazil, UFRGS, and from FH St. Pölten in Austria. This work is called Empathy and the Phantom Limb Sensation, a multisensory experience for the embodiment of amputation. So the context in which this work first came to be was the 3DUI contest at the IEEE VR conference, which happened in March. The main theme of the contest was embodiment for the difference, and the challenge was to build a VR experience that would enable people to feel the difficulties that people with disabilities felt in their everyday lives, as to promote empathy. There, the application entries would be judged for their novelty, the empathy they provoked, and their aesthetics. To participate in this context, we could pick any different human conditions. So in our case, we developed a small brainstorm session, came up with some ideas, and decided on the phantom limb sensation, or PLS. So PLS is a condition that is commonly suffered by people who have had any limbs amputated from their bodies. What they usually feel is being touched, itchiness, or even pain in a part of the limb they no longer have. Reportedly, this is felt by about 80% of amputees, and it usually lasts for about 2 years after the amputation happens. In our research, we found several studies that try to use VR to lessen the effects of PLS by replacing the amputated limb with a simulated virtual limb, gradually letting their brains feel accustomed to the lack of a member there. These studies proved to be very effective on the pain relief for these people. In our case, we're trying to accomplish the opposite of this, getting people with intact limbs to go through the same experience, the experience of having had a limb amputated. Our intention is to promote empathy for these people through embodiment, which in this case can be summarized as changing the user's own virtual representation in VR. To accomplish this change, we developed a multisensory simulation experience where more than one of the user's senses are played with, as to enhance their sense of presence inside our VR environment. So to get to this experience, we decided to use VR to transport the user's sight and hearing into our virtual world, as well as both passive and active haptics to simulate their virtual touching experience. To get there, the Vive head-mounted display was used as a visual portal. Attached to it is a lip motion hand tracker, which gets the position for each of the user's real hands into our application, as well as their fingers. Finally, we use the Exos Wrist, which is a haptic device that applies different levels of force to two axes of the user's hand. For our particular setting, the simulated amputation occurred in the forearm, near the elbow. So our access device was placed along the user's arm, with its rotation axis set in the elbow instead of the wrist, as it is usually meant for. The environment the user is able to see is a virtual table set in front of him, divided in two by a small obstacle in the middle. In reality, only the left half of this table exists, also with real tangible objects on top of it, matching the virtual ones. On the other hand, figuratively and literally, the right half of the table is purely virtual, as well as the objects on top of it. This was made to allow the user's non-existent virtual hand to go through the table, simulating that the arm they do have doesn't exist. Haptic feedback is provided on the tip of the elbow to simulate the existent part of the virtual arm touching the side of the table, as well as the virtual objects. I'm replicating this image here from a previous slide to help illustrate the scenario. The left hand will be able to feel everything it touches due to passive haptics of the real objects. The right hand won't feel anything except for the user's proprioception, which is actually felt by PLS patients. This confusion between feeling things in a non-existent limb will be maintained. To let users test out our experience, we developed two simple tasks. Both with the right and left hands, one at a time, users were asked to move objects on top of the table to colored targets. On the left-hand side, they're able to simply grab the objects and place them there, with all tactile feelings being intact. On the right-hand side, however, if a user tries to grab an object, their hand would just go through them. Just like an amputee, they need to get used to using the rest of their limb to push the objects around until they reach the targets. Again, the tactile feeling of the objects and the table here are being emulated by the haptic device in their arms, since the objects are only virtual. I'm going to play a video now demonstrating our working prototype. As to assess the validity of this experience, we intended on applying a self-presence questionnaire after each trial of our demo at the VR conference. However, because of the COVID-19 pandemic, the event was moved to a purely online instance, and the demonstration happened only via video, so the tests couldn't be done as planned. Anyway, our proposed questionnaire had simple questions answerable in a 5-point Likert scale, regarding how much users agreed with each statement, and the results would demonstrate how much people felt as part of the simulation. In the next steps, We still need to apply these tests to a number of actual users before expanding the project, as to understand the effects of this type of simulation on people. Based on the feedback of people, we'll be able to work more on the implementation and maybe replace any piece of hardware according to necessity, as to reach a more realistic simulation. Given that the application reaches good usability and embodiment levels, a more complex set of user tests and assessment will be developed as to proceed with the project, which will most likely require working alongside experts to put it in the right direction. In conclusion, this work was a proposal to figure out whether and how VR and haptics can be helpful in the context of promoting empathy via embodiment. Thanks everyone for your attention.
Okay, thank you very much also for this really interesting presentation. And actually, yeah, I also think this is a quite nice example of what VR actually could do to help in health-related topics. So, like for the other papers, please come up with any questions or suggestions, notes, and so on in the chat, and we'll be happy to point them and post them to the authors. And I just saw actually that the first question already popped up. So yeah, it's a comment first, which I also wanted to share with you. Awesome work. Congratulations. So the question is, did you also cooperate with physicians or therapists? And if yes, was there a feedback by them? And what was this feedback?
First of all, thanks again for the time here. Regarding the question, we didn't have let's say a proper I'm missing a word here, but a proper meeting with a therapist or a physician, since our time since the whole application was meant for the VR conference, and our time to develop it was limited. But actually the wife of both my and Victor's former advisor in Brazil is actually a therapist. So we did informally talk to her and got some feedback from her. What we meant to do was, like, after this project was done and the initial tests were done, we intended on getting proper recommendations and exposing it to physicians and therapists or people specialized in the PLS syndrome. But we couldn't finish the test in time because of the whole pandemic situation. So that is still pending.
Okay. Yeah.
Are you planning to do tests also on some real amputees, for example, who like have removed their leg and something, to test out how well your sensation created by the VR device is compared to their pain or sensation?
We haven't. I don't think we have thought of, or at least discussed that, but it is a really interesting idea. I do think it would be interesting to get their take on it.
Yeah, I don't know if I can add something, but I would say that the application was designed, even though it could be used for treating, I think it was more on the social aspects than really the medical aspect of it, especially on allowing people that do not have the impairment to have a sense of how it could be. And in these terms, I think we wanted also to demonstrate that perhaps having this multisensory experience would allow for more embodiment and be a little bit more representative of it. Yeah, and I think it's worth mentioning that also this application was also rewarded in the 3D UI context. winning the challenge of designing this application for embodiment of the difference, in which we had a lot of different applications for different impairments as well. So I think it's worth mentioning that as well.
In my opinion, what also makes it interesting is that you're doing it exactly the other way as usually it is done, so that you're trying to use the non-reality to create tactile feedback. I think that's very innovative approach. What was your experience here with the people trying it out? How long did it take them to get used to this way of not tactile feeling something when touching the objects, but just using the haptic feedback? Was this easy for them to do, or what's your experience on that?
Yeah, so the problem here is that since the conference where we wanted to test everything didn't happen,
yeah, okay.
We ended up not really testing it with anyone besides the people who were already like into the project. So well, from my experience at least, it is a bit weird at first, but you do get quite a good feeling on it after not a very long time.
Yeah, because I think what could be very interesting to then, once the people have a feeling to it, just from one day to another, change the type of haptic feedback so that it is either on another part of your body or something else, and then see how everything changes now. I think that there are very interesting follow-up options on this regarding such options.
For sure.
Okay, a lot of questions coming up. So first one I'm taking is from Clemens. Also, first of all, he thanks you for your very interesting presentation, and he wants to get more details on the questionnaires that you did use. So he asks whether you also looked at other immersion or presence questionnaires, and also he wants to know what are the reasons why you did choose the self-presence questionnaire.
Yeah, so what we intended on doing was getting like a preliminary test going. So we figured we wouldn't have a lot of time to test it with different people at the conference. Like it would be like just a small amount of time. So we wanted a really short questionnaire that encompassed most of the stuff that we wanted to like measure. We did look through quite a few other questionnaires, but this one, since it was really short and easy to answer, we ended up choosing it.
Okay. One other question coming up. First of all, some background information, so that actually there are some kind of suits to emulate how it feels to be an elderly person, which is a funny idea. So difficulties in walking or raising up or raising your hand. Are there any other possible applications of your work you're thinking of for which it could be interesting?
Interesting. You mentioned that. I just remembered that here at the university I'm in right now, they at least a few years ago, there was a similar test where people were testing like the feeling of being in like in of course like for embodiment, but like being in the body of a obese person. So you like get a full suit with like different padding along your body. I don't know enough details to know what they wanted to get it, but it is similar to what you mentioned. I don't think we planned it as far as that. We wanted first to get everything right on what we intended on reaching, and since we came to a halt there, we kind of got stuck and started doing some other things. So we're still waiting to do the testings. I don't know if Victor has a different opinion on it.
No, I agree. So the idea would be to pursue many other applications regarding environment, especially if we deal with the basic visual sense, we could do many of different applications just using the headset. For instance, we could work on different social areas. We could work also with gender and not only impairment, but we wanted to have this first case study and then see what would come out of it, and perhaps exploring different topics as well.
Can you maybe elaborate a little bit more your type of collaboration? How did you work together? We just know that you did, but not how.
Oh, okay, yeah. So when we, like, back in my lab in Brazil, when we first heard about the challenge at the conference, we me and Amy, which is the one of the other authors, we got together and did like a little brainstorm session about which impairment we were going to choose to work on. And then after we got a few options, we emailed everyone in the lab asking who wanted to be a part of it. So we got together, we discussed it with Victor already. And so the moment that we chose this application, I started implementing it a bit before I came here to Sweden. So the moment I came here, I left the implementation part to some of the other some of our other colleagues who eventually finished it. We got the extended abstract going for the VR conference, and then after we presented there, we actually won the contest there.
Wow!
We got the
Congratulations.
Thanks. Yeah, we're really happy about that. And I don't know, we've been mostly collaborating via Skype and talking, discussing which sort of way we should follow to get to our application.
And mostly on our own side. So it's not related to anyone's thesis or main project. It was just like a side work.
Yeah. For everyone. Yeah, no one's actually using this for their thesis or anything. It was basically like on out of our own interest to pursue this.
It's even cooler if it's your side work then.
Yeah.
Okay. Any other questions?
Well, there are two other congratulations from Julia König and from Wolfgang Eigner.
Thank you.
Congrats for the winning contest, well deserved. I have one question about the empathy, because I read about like VR is a new empathy machine and it's immersion, and it's a very controversial term. I mean, empathy machine could also mean, yeah, well, you can make people feel something that they don't want to, or some people say, or some papers say, well, is it really empathy, or is it not only like sensational stuff? Or so what's your stance on that?
Yeah, so the contest on the conference was actually kind of a reason to get into the whole discussion, like how we could promote empathy via virtual reality or extended reality applications. And at least from our take for this short paper, that's actually why we chose the title E-empathy. Like it's like sort of a digital empathy. Like we from our perspective as computer science or engineers or whatever, we can't like out of our own knowledge tell people what empathy is. that would be left for someone studying cognitive science or I don't know, philosophy. So we just wanted to contribute with what we thought we could.
Okay, then as usual, thank you very much also to these two speakers of the paper. A round of virtual applause. We should get some sound file for this actually, so that it's better to hear.
Well, we could also turn on the sound and then.
Yeah, we could actually, yeah. So yeah, thank you very much for taking part in this session, and want to once again say a big thank you to all of the speakers, to Irene, to Renan, and to Victor for sure. Also want to say thank you to Franziska, who did a wonderful job as a co-host of this session. And let me just give you a brief outlook what will still happen. So today in the afternoon, we will have the follow-up of the hackathon session. So all of the hackathon participants probably know about this already. And tomorrow, actually, it's coming sooner than we thought. Is actually the last day right now of our Exchange Reality event. So what will be coming up tomorrow is another day of a full and interesting program. So in the morning, we will have, as usual, every day at the hackathon session starting at 9. Then we will have also, as in the last 2 days, we will have the third paper presentation session starting again at 1:30 p.m. Tomorrow, the topic of this paper presentation session will be XR for theater and animation. Tomorrow we will only have 2 papers, not 3. That's also because tomorrow in the afternoon we will have the presentations, the final streaming presentations of the hackathon. So this is where all of the hackathon groups will be able to present their findings, their preliminary results, or their demos, images, whatever is coming out of the hackathon. And this will be also a public event. So this will be also streamed via Zoom and YouTube. And this will start at 3 p.m. in the afternoon tomorrow, and will last approximately about 1.5 hours until 4:30 p.m. And then we will have the long expected and highly appreciated party. So all of you who registered in time for the hackathon got a nice surprise by mail. So you got a small bottle of wine and stuff to just cheered up together with us and say Prost, as we say in Austria, cheers. Then after this party, so this is really a limited party only, so it's only 30 minutes, so we have to do a fast drinking then. We will have the final keynote of this event, and this will be the keynote by Peter Bell and Jacqueline Klusig-Eckert from Time Machine Europe. This will start at 5 p.m. tomorrow. And then after the keynotes and the usual question and answer session, we will have the official closing event tomorrow at 6 p.m. So that's a full program for tomorrow. So I hope you find now some time to have a brief break, grab a coffee or something else to drink and relax a bit before the hackathon continues. And thank you all very much for participating. Thank you all again to all the colleagues here on the panel for being here together with me, and see each other the latest tomorrow. Thank you. Bye.